Hi, welcome back to my channel. My name is Gina. In this video, we're going to talk about more derivative formulas. So far, we've looked at the power rule and derivative of trigonometric functions. If you want to review the videos, I'll put the link up there. So today in the video, we're going to derive more formulas. We're going to look at derivative of exponential functions and log functions. So let's start with the exponential functions. So here I need to introduce another special limit. Limit of e to the power of h minus 1 over h as h approaches 0. This limit equals to 1. And again, if you want to prove this, you need something called the Taylor expansions. So we are not going to prove this limit here. So let's prove the derivative function of e to the power of x. So as usual, we're going to start with the definition of derivative function. F prime equals to limit of f of x plus h minus f of x over h as h approaches 0. Now we can substitute the function to the f of x plus h and f of x. So this equals to limit as h approaches 0 of e to the power of x plus h minus e to the power of x over h. And we can expand the e to the power of x plus h to e to the power of x times e to the power of h. So this equals to limit as h approaches 0 of e to the power of x times e to the power of h minus e to the power of x, then over h. Now we can factor out the e to the power of x from the first and the second terms. So this equals to limit as h approaches 0 of e to the power of x times e to the power of h minus 1 over h. And this e to the power of x is a function of x, so it's independent of h. And since here we are taking the limit as h approaches 0, so e to the power of x is like a constant in this limit. So we can put the constant outside of the limit. So this equals to e to the power of x times limit as h approaches 0 of e to the power of h minus 1 over h. And if you can recognize this limit here is the special limit that I just introduced. And this limit equals to 1. So in summary, the derivative function of e to the power of x equals to e to the power of x, which is the same as the original function. Now, how about the derivative of ln function? So let y equals to ln of x, and ln function is a special form of log function with base e. And this equation is equivalent to e to the power of y equals to x. Now, in the last lecture, we've talked about the implicit differentiation. If you want to review the lecture, I'll put the link up there. So when we have an equation that implicitly defines a function for y, then we can use the technique implicit differentiation by taking the derivative on both sides and find the y prime. So let's take the derivative on both sides. Derivative of e to the power of y equals to derivative of x. And here we are assuming that y is a function of x. So when we take the derivative of y with respect to x, we have to use the chain rule. So the left-hand side equals to e to the power of y times derivative of the inside function by the chain rule. And this equals to derivative of x, which is 1. So now we can isolate for y prime. So y prime equals to 1 over e to the power of y. And since e to the power of y equals to x, so we can also write this as 1 over x. So derivative of ln of x is 1 over x. So a quick summary. In this video, we just proven the derivative of e to the power of x, which is the same e to the power of x. And if we have a composition function, So instead of x, here we have an inside function. Then by the chain rule, this derivative equals to e to the power of the inside function times the derivative of the inside function. And we've also proven the derivative of 1 of x, which is 1 over x. And if we have a composition function, instead of x, we have an inside function, then its derivative is 1 over the inside function times the derivative of the inside function. Now let's look at some examples. Y equals to 2x squared times 1 of x squared. So here we have a function of x times another function of x. And in front, we have a constant 2. So to find the y prime, we'll use the product rule and the multiple constant rule. So y prime equals to 2, the constant, times, here we'll use the product rule. So the derivative of the first function, which is 2x, then times the second function, ln of x squared, plus the first function, x squared, times the derivative of the second function. And the second function is ln of an inside function, x squared. So to find its derivative, we need to use the chain rule. So this equals to 1 over the inside function, x squared, times the derivative of x squared, which is 2x. Now let's simplify this. Here the x squared can cancel out with the x squared in the denominator. So this equals to 4x times 1 of x squared, and then plus 4x. Now let's look at the second example. Y equals e to the power of x squared plus line of sine of x. So here we have a function of x plus a function of x. So we'll use the sum rule. And here is e to the power of an inside function, where the inside function is x squared. So we have to use the chain rule. And by the chain rule, its derivative is e to the power of the inside function times the inside function prime. So y prime equals to e to the power of x squared times derivative of x squared, which is 2x. And then plus, here we have ln of an inside function. So its derivative equals to 1 over the inside function, sine of x, and then times derivative of sine of x, which is cosine of x. Now let's simplify this. So the first term equals to 2x times e to the power of x squared, plus cosine of x over sine of x is 1 over tangent, which also equals to cotangent of x. So that is the end of the video. If you have any questions, feel free to comment below, and I'll see you in the next video.